This is the concluding video for Chapter 3, Section 3. I'm on page 160. I'm at the bottom of the page. I just want to read a few things. You do need to go back and read all of it. But once a percentile graph has been constructed, one can find the approximate corresponding percentile ranks. So in this chapter, in this section of this chapter, you have looked at percentile. I want to come back and look at the graph. Finding values in their corresponding percentile ranks by using a graph yields only approximate answers. So definitely highlight that, underline that. But this is a great question to ask on the test to see if you're really seeing and understanding an X and Y axis. Several mathematical methods exist for computing percentiles for data. These methods can be used to find the approximate percentile rank of a data value, or to find a data value corresponding to a given percentile. When the data set is large, these methods yield better results, and then it shows some of the methods. But I want to look at the graph here. I want you to notice here it says cumulative. In other words, it is truly that. It is adding up. It's like snow. It is accumulating. And then here it mentions class boundaries. And so as you are looking at this number, like right here, well, let's just pick one. Well, let's go one way or the other. At the 40th percentile, all of the numbers are going to be 119.5 or below. At the 70th percentile, all of the numbers are going to be 135 and 5/10 or below. My part in saying this in the conclusion is pay attention to your horizontal and vertical axes, pay attention to where they cross, and pay attention to this word cumulative. I'd like to give you a few more things on our concluding video. I'm going over to page 164, and I want to tell you, if you haven't already, to take the IQR formula and add it here at this chapter 3 for our important formulas. Put it somewhere, put it really clear, be careful how you're putting them on there so that you can read them later. But I wanted to tell you to add the IQR formula, this one, to your formula card. I also wanted to come over, I wanted to go to page 165, and I wanted to look at deciles. We've talked about the quartiles, percentiles. I wanted to show you deciles. And decile is like tens. And so it's the same thing that we've been doing with quartiles, but this time it has a different way to look at it, and it's going by tens. And so here it shows the deciles are denoted by D's. I've had a student point out this looks like our currency. A dime is 10, and they correspond to percentiles. And the percentiles, looking at P sub 10, P sub 20, it's showing you how these go together. But remember, percentiles go from 0 up to 100, like our pennies. Quartiles are like our quarters, Q1, 2, and 3, and they show you what they correspond to on the percentile. But I wanted to point this one out. In the middle, if you're talking about the pennies, the percentile, what's in the middle of 100 pennies? 50. If you're talking about quartiles, quarters, how many quarters get you to half of a dollar? Well, 2 quarters, they get you to 50 cents. Deciles, dimes, how many dimes get you to half of a dollar? Well, 5. I just wanted to point that out in case you're kind of skimming and not looking extremely closely at the information. I know another video talks about outliers, but I do want to go ahead and point out the paragraphs at the bottom of page 168. The first paragraph contains the reasons for some outliers, and you should read that. I have this as an LOL. I'll wait on that, and I do want to throw in a note. When you do example 3, you can't see it. When you do 3-334, you'll notice that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. And you're going to find Q1, 2, 3. You're going to talk about the 5-number summary. But with 10 pieces of data, that's like the example you had in the videos, but you didn't have an odd number, you had an even number. So I just want to point out a note here that when you have an odd number of data, like 9 pieces of data, you're not going to include the median when you're calculating Q1 and Q3. I would take a picture of that, jot that down, but I wanted to point out that note to include with the video that you just saw. I want to finish up here, and again, if you were with me in class, I would have somebody reading this because it's pretty funny. There are no hard and fast rules on what to do with outliers, nor is there complete agreement among statisticians on ways to identify them. Obviously, if they occurred as a result of an error, an attempt would be made or should be made to correct the error, or the data value should be omitted entirely. When they occur naturally by chance, the statistician must make a decision about whether to include them in the data set or not. So there is some leeway when calculating your pieces of information, but you always report on what you did with your outliers. Finally, when a distribution is normal or bell-shaped, data values that are beyond 3 standard deviations of the mean can be considered suspected outliers.